Okay, so we are going to study the use the properties of logarithms. Okay, and I think it's better if I get closer. All right, so maybe I should not be using that light. Perfect. So far we have I'm going to start writing down. We have looked at logarithms with different bases, such as we did, no, I think I need the light, such as log base 6 of 5 or log base 8 of 13 and many more. Now, when we see just log of log base 10 of x, that's what it means. Okay, so they are implying the implied base is 10. That's why I said log base 10. So the way we're going to write it is this way. Log base 10 of x is the same as log base 10 of x. And this is what we call common logarithm. Okay? All right. Now, our calculators, here's my calculator right here. Our calculators have our calculators work in base 10. And which one it is this one in the calculator. The log button on your calculator, okay? So, it says that without a calculator, this next exercises, I just want to do this. It says, without a calculator, find the exact value of log base 10. Okay, so we're going to remember that recall that the logarithm lead us to the exponent. Remember that. So if I have log base 10 of 10, here is 10, right? And this is going to be, oops, 10 to 1 power. So my answer is going to be 1. Okay? And we're going to do some exercises. So we have, it says find the exact value, okay, of, and here's the first one, right here. So we have log base 10 of 1 over 100, okay? Sorry, let me move this. There we go. So what do I do? Log, this is going to be 10 negative 1, right? Equal to x. So I know this is 10. So we know 10 to the x power, this is the exponent, base to the exponent is equal to the log. Okay? Now, what do I have here? Hold on. I need to have the same base. I know 10 to the second power. So this is going to be 10x negative 2. So x is equal to what? To negative 2. That's the answer. So remember, let me write it here. Log base b of bx is equal to x. Okay? If b is replaced with 10, so it's going to be log 10x equals to x. All right? Just keep that there. Now, let's do number 2. It says log 1000. Log base 10 of 1000. All right, so 10, this is an x equal to what? To 1000. What is 1000 equal to? 10 to the third power. So x is equal to 3. That's my answer there. Now, number 3, log base 10 of 100,000. Okay, so this is going to be 10 to the x power to the answer is equal to 100,000. But 100,000 is equal to 10 to the 5th power. So x is equal to 5. This is 3. We can do 4 here. 4 is going to be log 1 over 10. So what do we do there? That will be 10. All right, so it's going to be 10x to the x power equals to 10. So x is going to be equal to negative 1. Number 5, I have log base 10 of the fifth root of 10. Okay, so this is equal to 10 to what? To 1 over 5, to the 1/5. So x is equal to 1/5. Now, let's do 6 log, and we have 0.001. So this one is going to be 10x, and this is 0.001. But what is this number equal to? 10 to the negative 3. Why? Because this is the same as 1 over 1,000. This number is the same as that. And what is 1 over 1,000? 1,000 to negative 3. So what do we have? X is going to be equal to negative 3. All right. Now, that's number 6, 7, log of 10, log base 10 of the square root of 10. So square root is 10 to the 1/2 because it's a square root. So x is equal to 1/2. Okay. Now let's do the last one that I have here. This is log of 1. So this is 0. When we do the 10 to the x power equal to 1, the x is going to be equal to 0. Because any number to the power of 0 is 1. Now, let's study about the natural. We were doing the common logarithm. Now we're going to be studying the natural logarithms. Okay? So now we're going to be learning about the naturals. Even though we think of counting in terms of normal, that we count 10 fingers and we have 10 toes, it is in fact an arbitrarily made up way of grouping quantities. So it seems like, I mean, think about it. If we had 8 fingers, I'm sure we will be counting in 8 fingers and 8 toes. And we will be counting in groups of 8. Although base 10 is considered common, there are different counting systems. And when I say different counting systems, I'm referring to, for example, when we're talking about a group of 13, is known as the baker's dozen. A group of 12 is a dozen, so one more is a group. The group of is the baker's dozen. I can't remember. I have a group of 20 is a score. A group of 144 is a cross. So now let's go back here, and the nature has its own way of counting or grouping. So nature uses base. They use a base of what? Of E. And E is equal to 2.7183. Okay? And is an element of the irrational numbers. So the natural logarithm is this one, log base E of x. But we are going to write it this is how we're going to write it. Natural logarithm of, and these two are the same. How do we read this? Ln of x. Ln of x. We read it as Ln of x. And it's the same as this. And here's where we locate it in our calculators, right here, Ln. So now, let's take a closer look at this. So we know that log base b of bx is equal to x, right? The exponent, like the ones that we just did. Now, let's use so we're going to use the base of e. That will be the natural log. So it's going to be like this. Log base e of e to the x power is equal to x. Okay? However, this one, log e to the x, is equal to what? This part is equal to natural logarithm. Okay? And this is equal to x. All right? So this is what we're going to be working for now on. Base e. Instead of saying log base e, we're going to use the ln of e. This is ln. That's how we use it. Now, we're going to find the exact value. It says find of, here's the first one, ln to the fourth power. What's the answer? 4, right? We just said it here. that it was going to be equal to the exponent, okay? Now, let's do the second one. ln, so what's it going to be equal to 3, okay? Number 3, ln, and we have 8th power of e. Okay, so then this one is going to be equal ln e to 1/8, right? So my answer is going to be 1/8. And let's do the last one here. Number 4, ln cubic root. So what do we do? E to 1/3. So my answer is going to be 1/3. Okay? And it's just because it's equal to the exponent. Now, let's do this one. It says that we need to give the exact solution, and we should have the solution to 4 decimal places. Put those 4 decimal places, okay? To 4 decimal place. Now, look at this one. It says natural logarithm 3x is equal to 5. All right? So now, one thing that we need to remember is that the ln is equal to this. 3x equals to 5. Don't forget, this part is equal to ln. So 3x is equal to what? To e to the 5th power. Look at this. This is exactly as this one. So it's going to be e to the 5th power. Now, what happened here? If I divide by 3 on both sides, it's going to be x is going to be equal to e to the 5th power divided by 3. And if we do that in the calculator, right here, look what I found it. Hold on, let me get my I thought I had my glasses there, but I don't. Okay, so this one, second button, right now it's asking me e to the what? To the 5th power. It's 148. I'm going to divide it by 3. So I got 49.47105. They want me to do it 1405. 4 decimal places. 1, 2, 3, 4. So if I'm rounding is going to be 4711. Okay, the 5 is greater than 5, so it's going to add 1. This is going to be the answer. Now, let's try this one. I have another one here that we could try. This one says ln 6x equals to 4. So again, remember that this is the same as 6x equal to 4. So then we could say e to the 4th power is equal to 6x. And remember that we need to solve it for x, right? So we're gonna divide by 1/6 on both sides. So x is going to be e to the 4th divided by 6. Again, go back here, shift, e to the 4th power. I got it, divided by 6 is 9.09969. So this is going to be 9.099 what? 7. And that's going to be my answer. Now, let's do this last part, which is a little bit different. How do we do? Here's the question. It says, how can we solve logarithms when we do not have a common or natural base? So the answer is use either the common or the natural base. It's your choice. So when we don't have, let me just show you. Here's the answer. Use either the common okay, and we are going to use the natural base, okay? So let me give you the example. It says, so we are using this one. So it says give log of 8, base 8 of 5. And they want us to have to 4 decimal places. Okay? So now let's do it to 4 decimal places. So we have log of 8, base 8 of 5, right? This one is not a base 10, and this one is not a base 8, right? So it's neither 10. So we are using, remember what we said, when we don't have that, we use either the common or the natural base. And we're using the natural base. So what do we do? Okay, so we know this is equal to x, right? And 8 to the x power, 8 to the answer, This exponent is the answer, remember. It's the log of 5. This is an exponential form, right? Now, we're going to take the natural number of both sides of the equation. That's what we're going to be doing, okay? So we have, and what I'm going to be doing is, on both sides, I'm going to be applying ln. Now, I'm going to apply the power rule. Apply the power rule. What's the power rule? The one that says that we need to bring this one, the exponent, to multiply it, equal to the ln of 5. Now, what do? X is equal to ln of 5 divided by the ln logarithm, the natural log of 5 divided by natural log of 8. And not 5 divided by 8, the natural number of 8. I got 0.7739397. 1, 2, 3, and 4, right? The 4 or 3, 4. So if it's 4.77 what? 4. So what I did in the calculator was just this one. Natural log of 5. I think we could close it. Divided by natural log of 8. And we can check this. And if we check this, 8, remember, we are 8 to the x power. So if I do 8 to the 0.774, I need to get 5. And let's do it and see if we get that. 8 exponent 0.774. Yep, that's a 5. So that's good. This we do it when we don't have a common base. So this is not a base 10 or a base E. That's when we apply that.